Okay, we're going to start this lesson by dividing a polynomial by a monomial, a single term. Let's take this as our first example. We're going to take this polynomial. We're going to divide by the monomial 3. Okay, so this is dividing, or divide by just a monomial for now. Divide by a monomial. Okay. What we do is we put that 3 under each part. I'm going to split this up. 3 goes under that term, the 3 goes under this term, and the 3 goes under that term. And then you simplify each fraction individually. And so this right here would be 5x squared. This right here would be 4x. And that right there is a 2. And I've divided by the number 3. Okay? Easy as that. Next example, 5m cubed minus 9m squared plus 10m. And I'm going to divide that by the monomial 5m squared. So just like the previous example, I'm going to split this up, put that 5m squared under each term. Like that, and like that. Divide each, or simplify each fraction individually. This right here is just going to reduce to m. This right here, those m squareds will reduce, but you will be left with 9/5, and so I'm going to leave that as 9/5. There we go. And then this right here would be simplified. It looks like you'd have a 2, but you'd have 10 over 5 is 2, but you got m over m squared. That would reduce. You'd have an m in the denominator. And that's fine for these. 2 over m. And that's it. You're done. You've divided it. Let's do one more where we divide by monomial. Let's take this example. 8xy squared minus 9x squared y plus 6x squared y squared, and we want to divide that by the monomial x squared y squared. It's supposed to be a 2 there. Let me fix that. 2. Okay. Yet again, I'm going to break this up into 3 smaller fractions. Minus 9x squared y squared over x squared y squared, and 6x squared y squared over x squared y squared. And let me write the answer down here. Simplify each one. If we simplify this fraction, that is going to be an 8 over x. If we simplify this fraction, that's going to be I think that's a 9 over y, isn't it? And if we simplify this right here, that's just a 6. And that is my answer. I've divided the polynomial by the monomial. Okay, now what if you're dividing by a something other than monomial, like a binomial? Let's take a look at that. Let's say we got 2m squared plus m minus 10, and we're going to divide by m minus 2. Now, this will not work. You can't split it up and put that m minus 2 under each part, because you just can't simplify each section. So this is not the way to go here when you're dividing by a binomial or any other polynomial. So no, don't do that. What we have to do is long division. 2m squared plus m minus 10, and divide by m minus 2. Okay, how do we start this sort of thing? This isn't the typical long division that you probably recall. And it's not that difficult. We start right here with that. You take that m and you have to think, okay, what do I have to multiply that m by to turn it into this? Well, to turn this m into 2m squared, you must multiply this m by 2m. So that's what I'm going to put up here. Now, if I take 2m and I multiply it to m minus 2, so I'm multiplying here, I end up with 2m squared, which is what we want, and you got to distribute that, and that's minus 4m. Okay, so 2m times m minus 2 is 2m squared minus 4m. Then you draw a line and you subtract, just like long division. Now, you got to remember to subtract the whole thing here. So this right here is going to cancel away. That's 0, and that's what we want. You always want that to occur. And this right here, if you combine that, keeping in mind this negative sign out here, is actually going to turn into a 5m. Okay, now that you've subtracted, you bring down the next term. So I'm going to take that 10 there and bring that down like that. And now I repeat the process over again. Let's use red for this now. I start here, and I have to figure out what do I have to multiply that m by to turn it into 5m. You have to multiply it by positive 5. So it goes right up there. Multiply. 5 times this m minus 2 is 5m minus 10. Draw a line and subtract. And if you subtract that whole thing, this remainder happens to be 0. Not always the case, but here it is. And so my answer is right up here. The answer to this division problem is 2m plus 5. 2m plus 5. This is just like the steps are equivalent to a basic long division problem that you would get in arithmetic. For instance, making one up here, if I needed 372 and I needed to divide that by 7, let's say. Okay, so you have to figure out, well, how many times does 7 go into 37? And it goes in 5 times. So you put 5 up there. Then you multiply the 5 times the 7 here to get 35, just like we did in the long division, or in the division problem right there. You subtract, then you bring down the next term, and then you repeat the process. 7 goes into 22 3 times. Then you multiply. 3 times 7 is 21. Subtract. And then you have your remainder 1. And usually we write the answer as would be 53. And then the remainder 1 over the divisor 1/7. 53 and 1/7. The steps are equivalent. Let's try another one. Let's look at Let's look at 2x squared plus x minus 21, and we want to divide this by x minus 3. Okay. I'm going to write as a long division problem. There we go. Now, by the way, the polynomials have to be in descending order. If they're not, you got to rearrange the terms first, or else this won't work. Okay, how do we turn this x into 2x squared? Got to multiply it by 2x. Now we multiply 2x times x minus 3, like a distributive property here. 2x times x minus 3 is 2x squared minus 6x. Subtract. Draw a line, subtract. Okay, so I'm going to subtract that. Should be the negative sign here. 2x squared minus 2x squared is 0. It's gone. X plus 6x is 7x. Now you're ready to bring down the next term, minus 21. And now we repeat the process. What do we have to multiply this x by to turn it into 7x? We need to multiply it by a positive 7. Now we multiply. 7 times this x minus 3 is 7x minus 21. Draw a line and subtract. And here this remainder is 0 again. And so my answer is 2x plus 7. Now, the remainder isn't always 0. Let me give you an example of that. For instance, this one right here, 3x cubed minus 2x plus 5, and we want to divide this by x minus 3. Okay, so I'm going to set it up correctly. X minus 3 goes out here. Now, remember I said that the polynomial has to be in descending order, and also every term has to be accounted for. If you notice right here, you got an x cubed and then you got an x. The x squared term is missing. For everything to work correctly in the long division process, all the terms must be accounted for. So if a term is missing, you have to put in a 0 as a placeholder. And so I'm going to write this as 3x cubed, a 0x squared as a placeholder for the missing x squared term, minus 2x plus 5. So now it's in descending order, 3, 2, 1, 0 for the exponents. Okay, now I'm ready to perform the long division. So we start this just like the other problems. How do I turn x into 3x cubed? I have to multiply by 3x squared. Okay? 3x squared times this x minus 3 is 3x cubed minus 9x squared. Draw a line and subtract. Subtract that. The x cubed term cancels away, which is what we want. And this here, if you distribute that negative sign appropriately, you end up with 9x squared. I'm ready to bring down the next term. So this comes down like that. And now we repeat the process. What do I have to multiply this x by to turn it into 9x squared? I've got to multiply it by 9x. Now I multiply 9x times this x minus 3. That would be 9x squared minus 27x. Draw a line and subtract. Minus. Okay. All right, the 9x squareds are gone. If you distribute this negative sign correctly and add, you end up with 25x. We're ready to bring down our last term. So it's 5. Don't forget the 5. Comes all the way down, like that. And now we repeat the process one more time. What do I have to multiply this x by to turn it into 25x? I have to multiply it by a positive 25. Multiply 25 times x minus 3 is 25x minus 75. Draw a line and subtract. $25x is gone, and that gives me a remainder here of 80. So we have a remainder here. So how do we write the correct answer? This division problem is equal to 3x squared plus 9x plus 25 plus the remainder 80 over the divisor x minus 3. There's our answer. All right, let's try one more where we divide by binomial. Let's look at this one. (3k cubed plus 9k minus 14 over k minus 2. Notice that the squared term once again is missing here, so I got to put that in as a placeholder. 0k squared 9k minus 14, like that. Okay, so now we have it correctly set up. Now I'm going to perform the long division here. Just like the others, it's exactly the same process. To turn k into 3k squared, we've got to multiply by 3. I'm sorry, let me say it again. To turn k into 3k cubed, you got to multiply by 3k squared. 3k squared times k minus 2. 3k cubed minus 6k squared. draw a line and subtract. If I subtract that, this is 0 k squareds, and this becomes positive 6k. Let me say it again. I keep saying the wrong thing here. 3k squared minus 3k cubed minus 3k cubed is 0. 0k squared plus 6k squared is 6k squared. I'm ready to bring down the next term, 9k. And now we repeat the process. How do we turn this k into 6k squared? It must be multiplied by 6k. 6k times k minus 2 is 6k squared minus 12k. Now we subtract. Subtract. That's 0. And that, combined with the 9k, is going to be 21k. I'm ready to bring down the next and last term here. And we're doing this one more time. How do I turn k into 21k? I have to multiply it by positive 21. 21 times k minus 2 is 21k minus 42. Draw a line and subtract. The 21k's are gone, and then this is a positive 42 minus a 14, which is a 20, is that a 28? 28, yeah. There's a remainder. So our answer is 3k squared plus 6k plus 21 plus the remainder 28 over k minus 2. There it is. All right, let's see what we have here. Let's take a look at this one. 2p cubed plus 5p squared plus p minus 2, and we're going to divide that by 2p plus 2. Let's see what happens when we try this one. How do we turn 2p into 2p cubed? You have to multiply by p squared. So p squared times this 2p plus 2 is 2p cubed plus this times this is 2p squared. There we go. Now we draw a line and subtract. Subtract. This part is 0, but this right here will turn out to be 3p squared. Okay, 3p squared. We bring down the next term. Okay, now we repeat the process again, but we come across something that might be a little tricky. How do I turn 2p into 3p squared? Well, I have to multiply, let me put it over here. 2p, and I need to turn it into 3p squared. Well, how do I turn a 2 into a 3? The trick is you've got to multiply it by 3 halves. So you want to get rid of the 2, so you put a 2 in the denominator, and then you put a 3 in the top. So I've got to multiply that 2 by 3 halves to turn it into 3. So the 2's would then cancel. And it needs to be a p squared, so I need a p in there as well. So I have to multiply by 3 halves p. I have to multiply by a fraction. So let me go back here. To turn 2p into 3p squared, I have to multiply 2p by 3 halves p. Okay, now the process is the same as before. 3 halves p times this 2p plus 2. Well, this will be 3p squared, and then 3 halves p times 2 is 3p. Okay, now I'm ready to draw a line and subtract. Like that. 0 there, and this will end up being negative 2p. I'm ready to bring down the last term, way down there. And repeating the process one more time, how do I turn 2p into negative 2p? I have to multiply it by negative 1, which gives us this. Draw a line and subtract. Oh, wait a second. Negative 1 times this is negative 2p minus 2. Almost messed up there. Subtract. And here we do have a remainder of 0. And so our answer is p squared plus 3 halves p minus 1, and I have divided. Okay, so sometimes you've got a fraction in there you got to be careful of. All right, I think we have one more example. Yeah, we got one more example in this section. Let's take 6x to the fourth plus 9x cubed plus 2x squared minus 8x plus 7, and we need to divide this by, we want to divide this by 3x squared minus 2. So I'm dividing by a binomial, but notice it's squared. Okay, so I'm going to rewrite it this way, and since I need a lot of room on the screen here, I'm going to kind of just fix the same problem I wrote down. That's under the division symbol, and this 3x squared minus 2 goes out here, but you'll notice that it's x squared, and then there's no x term. There's an x term missing, and remember, whenever a term is missing, you've got to put in a 0 as a placeholder. So I have to write that as 3x squared plus 0x minus 2 to make all this division work out correctly. Okay, so I'm going to erase this bottom part here. I put it out in front where I need it. I'll get rid of this line as well. Now I believe I have this problem set up correctly. All the terms are accounted for in descending order. 4, 3, 2, 1, and so on for the exponents. And this one is a bit longer than the others. It appears longer, but the process is the same. How do we turn 3x squared into 6x to the fourth? You got to multiply it by 2x squared. And now we multiply like before. We take this 2x squared and we multiply it by this trinomial out here. That'd be 6x to the fourth. A 0 times a 2, of course, is 0, but I'm just going to write it as 0x cubed for placeholder purposes. And then 2x squared times negative 2 is negative 4x squared. Okay, draw a line and subtract. Minus, subtract. Okay, that's 0. X to the fourth is gone. That's minus 0. Well, 9x cubed minus 0x cubed is 9x cubed. And then over here, that's a positive 4x squared plus a 2x squared is a 6x squared. So I'm left with that. Bring down the next term. That comes down. Repeat the process. How do we turn 3x squared into 9x cubed? You have to multiply it by 3x. 3x times this trinomial out here is 9x cubed 0x squared minus 6x. Draw a line and subtract. Subtract. This is 0. This is 6x squared, and this here, distributing that negative sign correctly, that's actually going to be a negative 8x plus a 6x is minus 2x. Okay. And we got one more term to bring down. That's 7. Bring it down and repeat the process one more time. How do we turn 3x squared into 6x squared? You have to multiply it by a positive 2. So that goes up there. 2 times the trinomial on the outside here is going to give us 6x squared 0x minus 4. Draw a line and subtract. The x squared terms cancel away. Here I'm left with negative 2x, and then that's going to be a positive 4 plus a 7 is plus 11. And that's our remainder because we're out of terms to bring down. And so the answer to this one would be written as, let's squeeze it in the bottom here, 2x squared plus 3x plus 2 plus the remainder, negative 2x plus 11 over 3x squared minus 2. All right, and that's our answer, and that's the lesson on dividing polynomials.